right, so in this lesson, I'm going to review how to make solutions. And there are two different specific cases that I might have. When I go into my stockroom, some of the substances that I have are solids, and some of them are actually already concentrated solutions. And so how I make a solution of certain concentration that I want depends on how the substance exists in my prep room. So the first example we're going to go over is how exactly do I make a solution if I'm starting with a solid. So in this example it says I need 250 mils of a 0.15 molar solution of sodium sulfate, and it comes as a solid. So I would go into my prep room and I would see that it's a solid. So first of all, which formula do I need to complete the math? So if you notice, the first formula here, molarity equals moles of solute over liters of solution, that is used to be able to determine the number of grams of solute I would need to add. The second formula is a dilution formula, and in a dilution what happens is you start with a concentrated solution and it's just helping you figure out how much of that concentrated solution that I need, and then I'm just going to add water to that. So since I have a solid, the only way to measure a solid is by determining the mass of it that I need. And so I'm going to be using this first formula here. Okay? So it says, describe how you would make the solution, making sure to show the math that is required. So first of all, I need to use this formula. I know that the concentration I want is 0.15 molar. Okay? I don't know the number of moles of solute I need. That's what I'm solving for. But I do know the volume that I want, 250 mils. Now keep in mind, this is in milliliters right now, and to use my molarity formula, I need to be in liters. So I'm going to put mils on bottom and liters up top. 1 mil is 10 to the negative third liters. And so what that tells me is my volume is going to be 0.250 liters. Okay, so if I then take 0.15 and I multiply it by 0.25, what I get for my number of moles is 0.0375 moles. Okay? However, there's an issue. I cannot measure moles in the lab. Instead, the only way to measure this number of moles in the lab is to determine the mass. And I can easily do that by converting from moles into grams. Okay? So to do that, I need to know the molar mass of sodium sulfate. Well, if I look, sodium has a molar mass of 22.99. There are two of them, so I'm going to multiply by 2. Then I'm going to add to that the molar mass of sulfur, which is 32.066. Then I'm going to add to that the molar mass of oxygen, which is 15.999, multiply by 4 because I have 4 oxygens. So the molar mass of sodium sulfate is 142.042 grams for every 1 mole. Okay, so now what I'm going to do is take the number of moles, 0.0375, and multiply by my molar mass. And what I get, unrounded, is 5.327 grams. Keep in mind 250 has 1, 2, 3 sig figs because there's a decimal there. 0.15 has 2 sig figs. So this is going to round to 5.3 grams. Now the question is not asking how much sodium sulfate do I need, it's asking you to describe how you would make the solution. So since this is a solid, the first thing that you're going to do is you're going to weigh 5.3 grams of your solid on a scale. And then once you've weighed it on the scale, you're going to add it to a graduated cylinder. And then you're going to add enough water to get a final volume of 250 mils. Okay, let's look at the next example. All right, so for this next example, it says I need 150 mils of a 0.20 molar solution of sodium hydroxide. I have a 1.5 molar stock solution. So in this problem, rather than having a solid, what you would see is just a solution in a bottle that's more concentrated than what I want. And so as a result, you're going to be using your dilution formula here. Okay? So M1 V1 equals M2 V2. I like putting my M1 and V1 in as the solution that I want to create. You can also make that your M2 and your V2. It doesn't matter, as long as this volume of 150 mils and this concentration of 0.2 molar go together. But I'm going to make this my M1, I'm going to make this my V1, and I'm going to make this my M2. And so when you solve this, M1 is your 0.20 molar, your V1 is your 150 mils, okay? My M2 is 1.5, and my V2 I'm trying to solve for. Notice I didn't convert this V1 volume into liters. You can keep it as milliliters. That's perfectly fine. What it does tell you, though, is that your V2, when you solve for it, that will be in milliliters. Okay, so I'm going to take 0.2, I'm going to multiply by 150, and then I'm going to divide by 1.5. And so what I get, V2, is 20 mils. Okay, let's figure out really quickly. I'm going to want 1, 2, 3 sig figs from 150, 1, 2 from 0.20 molar, and 2 from 1.5 molar. And so as a result, I need to make this 20 point to make it 2 sig figs milliliters. Okay, so the step that I'm going to do, first I need to measure out this volume of stock solution. And I'm going to do that in a graduated cylinder. Okay, now that I have measured out my volume of concentrated solution, then I'm simply going to add enough water to get a final volume of 150 mils. Okay. So just as a quick reminder, in the first problem, in the first example that I gave you, you have a solid. And so you weigh out the amount of solid that's needed, and then you add enough water to get your final volume. And that will then give you a 0.15 molar solution that has a volume of 250 mils. In the second example problem, now I have a stock solution that I'm trying to dilute. So I first have to measure out the amount of stock solution that I need, and then I'm going to add enough water to dilute it to get the final concentration that I want, which is 0.20 molar, and the final volume that I want, which is 150 mils.